In today's lecture, we are going to solve the solved examples based on the properties of parallelograms. Let's begin. First question. In parallelogram ABCD, angle A is 125. Find angle B, angle C and angle D. Very simple, very easy question based on the properties of parallelograms. Let me draw a parallelogram. So angle A is 125 degree. You have to find angle B, angle C and angle D. First of all, angle A is equal to angle C is equal to 125 degrees. Opposite angles of parallelogram. Opposite angles of parallelogram are equal. Secondly, angle A plus angle B is equal to 180 degree. So angle A is 125 plus angle B is equal to 180 degree. So angle B is equal to 180 minus 125. So angle B is equal to, okay, this will be 55. Also, the reason we have to mention is adjacent angles of parallelogram are supplementary. Okay. See, angle B is equal to angle D. Opposite angles of parallelogram are equal. So angle B is equal to angle D. So angle B, which is equal to angle D, is equal to 55 degrees. 55 degrees. Right? Cool. Okay, so you got all the angles. Angle A and angle C are 125 each. Angle B and angle D are 55 each. Let's go to the next question. So ABCD is a rhombus. Angle A is 66 degree. Find angle CDB. Great. Angle A plus angle D is equal to 180 degree. Adjacent angles of rhombus, because rhombus is a parallelogram, so adjacent angles of rhombus are supplementary. Adjacent angles of rhombus are supplementary. So angle A, which is 66 degrees, angle D we don't know, equals 180 degree. So angle D is equal to 180 minus 66, which is 114 degrees. Angle D is 114 degrees. Now we know that diagonals of a rhombus bisect the angles at the vertex. Diagonals of a rhombus bisect the angle at the vertex. Okay, therefore angle ADB is equal to angle CDB, which is equal to half of angle ADC. Since diagonals of a rhombus bisect the angle at the vertex, this part of the angle will be equal to this part. So therefore, angle CDB is equal to half of angle 114, that is angle D, ADC. So angle CDB is equal to 57 degrees. CDB is equal to 57 degrees. Let's check the answer. Yes. So they have done it by angle sum property and I have used the property of rhombus. Doesn't make any difference. We got the same answer and both are legitimate methods. Next question. In the figure, ABCD is a square. A line segment DP cuts BC at P. Okay, so let's see, there is no need to write given and everything because this is not a proof, but still you should know that what you have to find and what is given. So a line segment DP cuts BC at P and diagonal AC at O such that angle COD is 110 and angle OPC is X. Find the value of X. Okay, very nice question. So you can say that angle DOC plus angle COP, DOC plus COP is equal to 180 degree. The reason being linear pair. Angle DOC plus angle COP is 180 degree. DOC is 110 plus angle COP, which we don't know, is equal to 180. So angle COP is equal to 180 minus 110, which is 70 degree. So this angle is supposed to be 70 degree. Okay, one more thing we know, that diagonals of a square bisect the angles at the vertex. Diagonals of a square bisect the angles at the vertex. Therefore, AC bisects angle C. Therefore, angle DCA is equal to angle ACB is equal to half of angle DCB, which is half of 90 degree, which is 45 degrees. Angle DCA is equal to angle ACB, which is equal to half of angle DCB, which is 45 degrees, half of 90 or 45 degrees. Okay. Now, in triangle COP, angle OCP plus angle COP plus angle CPO is equal to 180 degree. The reason being angle sum property. OCP is this angle. We just found that angle OCP or ACB, which is equal to 45 degrees. Okay, so this angle is how much? 45 degrees. Angle COP is 70 degrees and angle CPO is X. We had to find the value of X. Right? So X is equal to 180 minus 45 plus 70, that is 115 degrees, which is 65. X is equal to 65 degrees. Right? So the value of angle X is 65. Let's check the answer. Absolutely correct. Okay, let's go to the next question. ABCD is a rhombus. Let me draw this figure. A, B, C, D is a rhombus with ABC equals 54 degrees. This is 54 degrees. Determine angle ACD. ACD is this angle. We have to find angle ACD. Cool. So angle ABC plus angle DCB is equal to 180 degree. See, this angle plus this angle, these two angles are equal to 180 degree, the sum of these two angles. So angle ABC, which is 54 degrees, plus angle DCB, which we don't know, is equal to 180 degree. Therefore angle, okay, the reason being adjacent angles of parallelogram or rhombus, because every rhombus is a parallelogram. So angle DCB is equal to 180 minus 54, which is 180 minus 54 is 126 degrees. Angle DCB is 126 degrees. So therefore angle DCA is equal to half of angle DCB. Why DCA is half of DCB? Because diagonals of a rhombus bisects the angle at the vertex. Diagonals of a rhombus bisect the angle at the vertex. So therefore angle DCA is equal to half of 126 degrees. So DCA is equal to half of 126 is 63 degrees. So angle ACD or DCA is equal to 63 degrees. Let's check it out. Yes, the answer is absolutely correct. Okay, so our method is also simple and we got the answer correct. Next question. We have to draw a square. Okay, let's say this is square ABCD. We have to find angle DCA. So for this we have to draw two diagonals. DCA. This is the angle DCA which we need to find. Okay, this is very easy. So ABCD is a square. So therefore angle ADC is equal to 90 degree. Since ABCD is a square, each interior angle will be 90 degree. Also AD is equal to DC. All the sides of the square are equal. Therefore we can say that in triangle ADC, angle ACD is equal to angle CAD. In triangle ADC, angle ACD is equal to angle CAD. Angles opposite to equal sides. Angles opposite to equal sides. Okay. So, therefore, angle ACD plus angle CAD plus angle ADC is equal to 180 degree. Angle sum property. So angle ACD plus angle CAD plus 90 is equal to 180 degree. So angle ACD plus angle CAD is equal to 180 minus 90. So angle ACD plus angle CAD is equal to 90. Now ACD and CAD are equal. So we can say that therefore 2 times angle ACD is equal to 90 degree and angle ACD is equal to 90 by 2, which is 45 degree. Angle ACD is 90 by 2, which is 45 degree. Let's check the answer. Okay, let's go to the next question. So these are mostly the questions based on finding the unknown angles. Just like, in triangles also we had similar kind of exercise. So ABCD is a rectangle. So each angle will be equal to 90 degree and opposite sides are equal and diagonals are equal. Angle BAC is 34 degrees. This is 34 degrees. Remember, this is 90 degree. You have to find angle DBC. You have to find angle DBC. This is the angle you need to find. Okay. See, this is very easy. We know that AC is equal to BD. Okay. Diagonals of rectangle. Diagonals of rectangle are equal to each other. AC is equal to BD. Okay. Also, we know that AO is equal to half of AC and OB is equal to half of BD. Why? Diagonals of rectangle bisect each other. Diagonals of rectangle bisect each other. Okay. So AO is half of AC, OB is half of BD. Great. Okay. So we can say that therefore half of AC is equal to half of BD, which implies, see, AC is equal to BD, so half of AC will be equal to half of BD, and which implies that AO is equal to OB. Okay, so we have proved that AO is equal to OB. So in triangle AOB, angle OAB will be equal to angle OBA. Angles opposite to equal sides. Angles opposite to equal sides are equal. Okay, so angle OAB is equal to angle OBA. So therefore, angle OAB is equal to angle OBA is equal to 34 degrees. So this angle is also 34 degrees. Now, angle ABO plus angle CBO is equal to angle ABC. So angle ABO is 34 degrees plus angle CBO or DBC is equal to 90. Why? Because angle ABC is 90. Therefore, angle CBO or DBC is 90 minus 34. Alright, 90 minus 34. See, 90 minus 30 is 60. 60 minus 4 is 56. So, angle DBC is equal to 56 degrees. Let's check the answer. Absolutely correct. Let's go ahead. So as you can see, the questions are pretty simple, straightforward questions based on the properties of parallelograms. We will come across proof questions as well ahead in the chapter in the solved examples. In the figure, ABCD is a parallelogram. Compute the values of x and y. Okay. See, if ABCD is a parallelogram, angle ADB is equal to angle DBC. Angle ADB is equal to angle DBC. Alternate interior angles. So angle ADB is 28, angle DBC is 7y. So 28 by 7 is equal to y. So y is equal to 4 degrees. Okay. Also angle ABD is equal to angle BDC. Alternate interior angles. So ABD is 12x is equal to BDC, which is 7y. I'm sorry, which is 60. BDC is 60. So x is equal to 60 by 12, which is 5 degrees. So y is 4 and x is 5. Okay, so there is a figure over here. I need to draw the same figure and need to find the angles A, B, C, D in parallelogram. Let me just draw a parallelogram first. Oops. Okay, our parallelogram is slightly different. Let's draw like this: A, B, C, D and join BD. Okay, so we have 2x, 3x and 5x. 2x is in the bottom. 2x, 3x, 5x. We have to find all the 4 angles of the parallelogram given this information. Okay. Now remember that angle A is equal to angle C, which is equal to 5x. Opposite angles of parallelogram are equal. Okay, so this is 5x as well. Okay. Angle CDB is equal to angle DBA. Angle CDB is equal to angle DBA, which is equal to 3x. Alternate interior angles. So this is equal to 3x. Right? So angle ABC is equal to 2x plus 3x, which is 5x. So therefore angle ADC is equal to angle ABC, which is also 5x. Why? Because they are opposite angles of parallelogram. So all the angles of parallelogram are equal to 5x. So therefore 5x plus 5x plus 5x plus 5x is equal to 360 degree. Angle sum property. So 20x is equal to 360 degree. So x is equal to 360 divided by 20, which is 18 degrees, and therefore 5x is equal to 5 multiplied by 18, which is equal to 90 degrees. So every angle of this parallelogram is 90 degrees. So this parallelogram is a special kind of parallelogram, which is a rectangle or a square, we don't know, but it is definitely a rectangle. Yes, every angle is 90 degree. Okay, let's draw this figure. So in our figure we have something like this. uh, A, B, C, D is a parallelogram, and line segments AX and CY. Okay, I have to name it a little bit different. So the parallelogram becomes A, B, C, D, and the line segments AX and CY bisect the angles A and C. So this angle is equal to this angle, and this angle is equal to this angle. Show that AX is parallel to CY. AX is parallel to CY. Okay. See, uh, first of all, let's write what is given, what is to be proved. Let's write that. Yes. So, given is that ABCD is a parallelogram and AX bisects angle A and CY bisects angle B. AX bisects angle A and CY bisects angle B. Okay. To prove that AX is parallel to CY. Proof. See, first of all, angle A is equal to angle C. Why? Because they are opposite angles of parallelogram. Opposite angles of parallelogram are equal. So angle A is equal to angle C. So you can say that half of angle A is equal to half of angle C. And therefore, what is half of angle A? Angle XAY is equal to half of angle C, which is XCY. Angle XAY is equal to angle XCY. Okay, so that means these two angles are equal. Oops. Great. So angle A and angle C are equal, so half of angle A and half of angle C are also equal, right? Now, angle XCY is equal to angle CYB, alternate interior angles. So angle XCY is equal to angle CYB, that is this angle, right? Therefore, we can say that angle XAY, which is equal to angle XCY, which is ultimately equal to angle CYB. That means I proved that this angle is equal to this angle. And therefore, I can say that AX is parallel to CY since corresponding angles are equal. Corresponding angles are equal. Correct? Corresponding angles are equal. All right, okay. So that is about your parallelogram ABCD. Let's move ahead. Okay, the figure is something like this. The diagonals of parallelogram ABCD intersect at O. The diagonals of parallelogram ABCD intersect at O. A line through O intersects AB at P and DC at Q. Okay, let me just name it little differently because okay, but that doesn't matter actually. Let me draw the figure according to me and not according to the figure in solution. Okay, yes, so this is the line which we are talking about. A line through O intersects AB at P and CD or DC at Q. Prove that OP is equal to OQ. Okay. Okay, so we have to prove OP is equal to OQ. I think we can use congruency in this. Now see this. Angle APO is equal to angle OQC. Angle APO is equal to angle. We are considering triangle APO and triangle CQO. So in triangle APO, in triangle APO and triangle CQO, in triangle APO and triangle CQO, angle APO is equal to angle CQO. Angle APO is equal to angle CQO, alternate interior angles. Then angle AOP is equal to angle COQ, vertically opposite angles. And AO is equal to CO. Why? Diagonals of a parallelogram bisect each other. Diagonals of parallelograms bisect each other. So AO is equal to CO. So therefore, triangle APO is congruent to triangle CQ by AAS test. Okay, so we proved these two triangles congruent, and then we can say that PO is equal to QO CPCTC. CPCTC. OP is equal to OQ or PO is equal to QO. Okay, so did you understand why these two angles are alternate interior angles? Because they are formed between two parallel lines AB and CD, and the transversal is PQ. Vertically opposite angles, very easy. Equal sides because the diagonals bisect each other. Okay, so two triangles AOP and COQ are congruent to each other, and therefore PO is equal to OQ. Very easy. Okay, let's go to the next question. So they have drawn the figure like that, but yeah, their method of proving is absolutely same. Okay, next figure. A, B, C, D is a parallelogram. AB is produced to E such that BE is equal to AB. Okay, so this line is produced further to this point. This is point E such that BE and AB are equal. Prove that ED bisects BC. So we have to join D to E. Okay, and we have to prove that this DE bisects BC. Okay, so let's write given. Very nice question, this one. In parallelogram ABCD, AB is equal to BE, and we have to prove that ED bisects BC, that is OB is equal to OC. In given, we can write one more thing so that there is no confusion. ED intersects BC at O. ED intersects BC at O. So we have to prove that ED bisects BC or OB is equal to OC. Okay. Okay, now see this. AB is equal to CD. Opposite sides of parallelogram. AB is equal to CD. And we can consider triangle BOE and triangle DOC now. See, in triangle, okay, wait, before, yeah, I think we can start directly. In triangle BOE and triangle COD, in triangle BOE and triangle COD, BE is equal to CD. BE is equal to CD. Why? Since AB is equal to BE and AB is equal to CD. Therefore, BE is equal to CD. Angle BOE is equal to angle COD. Vertically opposite angles. Vertically opposite angles. Okay, so angle BOE is equal to angle COD. That is done. Also, angle BEO is equal to angle CDO. Alternate interior angles. Angle BEO is equal to angle CDO. Alternate interior angles. Therefore, triangle BOE is congruent to triangle COD by SAS test. Triangle BOE is congruent to triangle COD by SAS. I'm sorry, not SAS, AAS test. AAS. Okay, so we have proved that these two triangles are congruent. So we can say that therefore BO is equal to OC, CPCTC, and therefore we can say that ED bisects BC. Right, very easy questions based on properties of parallelogram and congruency. You can easily prove this. The final question of this part. ABCD is a parallelogram and E is midpoint of AB, and CE bisects angle BCD. Okay, E is midpoint of AB and CE bisects angle BCD. So this angle is equal to this angle. Okay, prove that AE is equal to AD. AE is equal to AD. Okay, it can be proved very easily. Let's write given ABCD is a parallelogram. E is midpoint of AB and CE bisects angle BCD. Okay, to prove is written over here. I'm just going to write proof directly. Okay, so we can say that angle DCE is equal to angle BCE given. These two angles are equal. Okay, we can also say that angle DCE is equal to angle CEB. Why? Alternate interior angles. Okay, so DCE is equal to angle BCE and DCE is also equal to angle CEB. So therefore angle BCE is equal to angle CEB. Okay, from 1 and 2. This is 1, this is 2. From 1 and 2, angle BCE is equal to angle CEB. Correct? Nice. Angle BCE is equal to angle CEB, and therefore here you can write from 1 and 2. And therefore we can say that BE is equal to BC, sides opposite to equal angles. Sides opposite to equal angles are equal. So BE and BC are equal to each other. Okay, but BC is equal to AD. Why? Because they are opposite sides of parallelogram. They are opposite sides of parallelogram. So we can say that therefore BE and sorry. So we can say that AD is equal to AE. Why? Since AE is equal to BE. AE is equal to BE, we know BE is equal to BC and BC is equal to AD. So we can say that AD is equal to BE, which is in turn equal to BE. Right? So AD is equal to AE. That's what the first thing we had to prove. Okay, after this we have to prove DE bisects angle ADC. DE bisects angle ADC. Now that too is very easy. Since AD is equal to AE, we can say that angle ADE is equal to angle AED. angles opposite to equal sides. Angles opposite to equal sides are equal. Angle ADE is equal to angle ADE is equal to angle AED. Okay. Also, angle CDE, angle CDE is equal to angle DEA. Angle CDE is equal to angle AED, you can say. Alternate interior angles. So angle ADE is equal to angle AED and angle CDE is equal to angle AED. Therefore, we can say that angle ADE is equal to angle CDE, and therefore we can say that DE bisects angle ADC. Okay, so this angle is also equal. Great. Now the last part, angle DEC being 90 degree. That is very, very interesting. Please pay attention. See, angle D plus angle C. Angle D plus angle C is equal to 180 degree. Why angle D and C is 180 degree? Because they are adjacent angles of parallelogram. Adjacent angles of parallelogram are supplementary. So angle D plus angle C is 180 degree. So half of angle D plus half of angle C is equal to half of 180 degree. Right? What is half of angle D? Half of angle D is angle EDC. Angle EDC plus what is half of angle C? Is angle ECD is equal to 90 degree. Angle EDC plus angle ECD is equal to 90 degree. Okay. So in triangle EDC, angle EDC plus angle ECD plus angle DEC is equal to 180 degree. But we already know that angle EDC plus angle ECD is 90. Right? So 90 plus angle DEC is equal to 180 degree. Therefore, angle DEC is equal to 180 minus 90, which is 90 degree. So angle DEC is nothing but 90 degree. Angle DEC is nothing but 90 degree. So this is how you prove all the required things, and this was a very nice question based on all the properties of parallelograms. So this was a good exercise. You came across different kinds of questions, and 8B will give you required practice of the same. Okay, so 8B, the whole 8B is homework. It has got around 21 questions, many questions for you to practice and complete. So this part is over. This was the second part of the chapter, quadrilateral. Now we are left with just one part of the chapter, that is midpoint theorem and its converse and intercept theorems. I think that much is more than enough for the whole chapter of quadrilaterals. Okay, so I'm going to see you in the next video. Please complete the exercise 8B. See you later. Bye bye.